Hi there, I'm Michael Cohn from Advanced Tubular Technologies. I'm the lead developer for VTube-LASER software that measures and qualifies tube shapes and then automatically corrects tube bending machines. Our customers sometimes are really challenged when they're trying to measure bend radii, and they want to measure and calculate bend radii consistently. And they ask, why do they have trouble doing that on shallow bend angles? I'm going to explain that today and how to overcome that kind of variance that they see in measuring shallow bend angles and then calculating the bend radius. Well, first of all, unlike bend profile measurements, radius values are not a direct measurement of the surface of a bend. They are the result of calculations derived from other geometric calculations like cylinders and truncated tori in order to calculate the radius itself. Now, what we know is true because of the mathematics involved is that the accuracy of a radius calculation is always diminished from the original surface point accuracy. And the question is, by how much? So what we can do is we can give you some ideas of what to expect when you're measuring different angled bends. For example, let's say you're measuring a 90-degree bend and you want to calculate the radius of that bend section. The variance in that radius calculation is going to be probably around 3 times greater than the measuring system accuracy. So a measuring system that has a 50 micron accuracy will return a radius calculation that varies up to 150 microns. However, as you decrease the bend angle, there's another story altogether. For example, on a 20-degree bend angle, the variance in a radius calculation may be something like 80 times. That's 80 times greater than the accuracy of your measuring center. So a 50 micron measuring center might return a variance of 4 millimeters in the radius calculation. And that's just because of the nature of the math and angles in the mathematics. So a solution for overcoming this variance is to measure surface points and calculate the same radius value several times to find an average in the variance. And VTube-LASER allows you to do that now using what's called the radius average calculator. And I'd like to show you how to use that in today's video. So let's go ahead and get started. The first thing you do is measure the entire part, and it's important to know where the center lines are in order to calculate the radius. So we're going to take extra care not to move the part after we're finished measuring it. Now I'm going to load the Scan Bend Profile control, and I'm choosing Bend 3, which is an 88-degree bend angle, which is going to return a very high degree of accuracy, low variance. Now I've also loaded the Radius Average Calculator, which is going to store all of the radii that I measure, and then automatically calculate the average values that you see below. The top average value is all of the radii in the list averaged, and the bottom radius value is taking only the highest radius value and the lowest radius value and averaging those two together. Now let's switch over to bend 2, which is less than 20 degrees. And we're going to see that the variance is much higher here. And this is where we're going to really need to use the average calculator. In bend 2, we're going to find the variation from low to high is going to be 220th of an inch. So for this radius, it's important to copy the average radius calculation back into the bend profile menu. So that's how easy it is to use the new radius average calculator. If you have any questions about what you've seen in this video today, please feel free to email me at support@advancedtubular.com. I'll be happy to answer your questions. Thanks for taking the time to watch this video. Have a great day.